So kind of starting the same way that we did last time. X to the fifth. Here's what x to the fifth squared means. It would mean 2 copies of x to the fifth. That's what that would mean, right? It would mean x to the fifth squared would mean 2 copies of x to the fifth. And then from last time we learned that if the bases are the same and you're multiplying, what do you do with the power? Add them. So if you add the 5 and the 5, you get x to the 10th. 2 squared to the third would mean 3 copies of 2 squared. It'd be like this: 2 squared, 2 squared, 2 squared. And so using the fact that if the bases are the same, even if there's 3 of them here, you just add the powers. 2 plus 2 plus 2 is 6. So this would be 2 to the 6th. What are we actually doing with these powers here? When you have a power and then another power outside of parentheses, what could you do instead of writing down the groups? Yeah, multiply the 2 together. That's what we're doing. So let's apply that here. This would be m to the 3 times 5 power, or m to the 15th. Now it's important you see the difference between like what you have here and how we have it written up here. Up here I have 3 copies of the 2, right? So I'm multiplying the same bases. The base is 2 and I'm multiplying it 3 times here, so I add the powers. Here I have m to the third to the 5th power, so the 5th power is outside the parentheses. In this case I'm multiplying the 2 powers. Here's how it works when there's a number in there with the letter. Okay, so watch this carefully. This is a spot where a lot of students at any level, and I'm not just talking about Algebra 1, but at any level of math, high school math, just make a mistake, is that you have to apply that second power to the 3 as well as to the variable x. It's like there's an unwritten 1 power on the 3, and what I've just done is I've multiplied the 2 times the 1 power on the 3. But if you can remember, apply this power to every number and every different letter that you see in parentheses. I think we talked about this a little bit yesterday. Okay, if you can remember that, it'll be helpful. So 3 squared is 9, and my final answer would be 9x to the 10th. This one, it's a little more natural to do it because you don't have the unwritten 1. There's something about when there's just a number to the first power, a lot of students will not apply this power outside the parentheses to it. They just forget. But here it's a little easier to see. So this would be 2 to what power? Like I'm taking this 3 and multiplying it by that 2. So it'd be 2 to the 6th, and then I take this 3rd power and multiply it by that, x to the 6th. And 2 to the 6th, I know 2 to the 5th is 32, so 2 to the 6th would be 32 times 2, or 64. That's x to the 6th. And then this one would be 2 to the 5th, m to the 5th, which is 32, m to the 5th. So what we're seeing here in rules, a couple things here. One is if it is a power to a power, multiply the exponents. That's what we observed here on these first 2. Is when it's a power to a power, you multiply the exponents. And if there are multiple items in parentheses, like you see on the right-hand side here, all raised to a power, multiply to each exponent in parentheses. And I even wrote in, don't forget invisible ones. I would write that in because that's what happens. Right? Don't forget invisible ones. This is like 2 plus 2. Figuring out where the next thing was. So don't forget to write down what's in parentheses. I think or at least cognitively think about what that means. Even if there's just a 2 here, there's an unwritten 1 power, and so you have to take 2 to the 5th power as well. If you're doing that, it's like the biggest mistake I see students make when it comes to exponential expressions and simplifying is not applying that 5th power to something like that 2 there. All right, got it? So here we go, just some simple examples, even one with fractions this time, so we got one with fractions in here. So what would this first one be? End of that 28, yeah, multiply the 4 and the 7. And this one, what we do with the fractional powers is we multiply. You can multiply straight across. I think I'll do that. It's 2 over 6, just so you see that I'm multiplying the fractions, and then we'll simplify it. Okay. You can just jump right in there. 7:30. At some point, I'll need to check your homework. And then simplify this. So this is x to the 1/3 power. So just a little aside for you. These fractional powers are the same as roots. So for example, if I wanted to take the square root of the number 4, another way to write it would be 4 to the 1/2 power. That's equal to the square root of 4. Square root of 4 is 2. If I wanted to take the cubed root of a number, here's the simple cube root, would be 8 to the 1/3. So 1/3 power means cubed root of 8. Have you guys seen this before? A little cube root symbol. It's probably as far as you've gone. But you can take cube root, 4th root, 5th root, whatever. And it's kind of the same idea. You're finding, on a cube root, you're finding the number that when multiplied by itself 3 times equals 8, and that would be a 2 here. So that's what these fractional powers mean. You're really not going to do anything with that this year, but when you get into Algebra 2, you will with them a lot, fractional powers. But, just fractional powers will show up, just leave it as a fraction. You don't need to write it in root form. Okay, just leave it as a fraction. But that's what the 1/3 power means, is cubed root. Try these down here, please. These 3. Just try them real quickly. Did you already do them? Try those 3 on the bottom, and then I'll put up an answer for us. You can do those. So because of the commutative property, it doesn't matter which order it's in. These are both p to the 20th. And then this is p to the 1/8. Good. Okay, you just leave it like that. Right, so here we have kind of a mixture of things going on. So we're going to use this new rule that we just learned, which we could write up here. We have a to the m all to the n. It's a to the m times n power. And then we're going to combine it with other rules here. So here's what I mean by that. First rule, I'm going to just copy down the y to the 3rd. Not going to do anything with that yet. I'm going to apply the rule that we just learned here with these exponents. I'm going to multiply the 5 over 2 times the -2. So I have times y to the, so 5 over 2 times -2 over 1 would be equal to -10 over 2 or -5, right? So multiplying 5 over 2 times -2 would give me a power of -5. So now I just used this rule. Now I'm going to go up and use this rule right here that says if you're multiplying 2 things that are the same bases, you need to add the powers, right? Go back over here. If I add the powers, I end up with y to the negative 2. Can I stop there? No. Because right here, part of being simplified means no negative powers. So what do I do to remedy the negative powers? Yeah, put it below. So it'll look like this, 1 over y squared. So that's what I mean is that we're building. So we used 3 out of 4 of our rules of exponents in that one problem. Okay, why don't you take just a few minutes, actually, like 3 or 4 to do these two. So try these right now. I'm going to come around and look at them. Maybe have recording purposes here. So we got, for this one, it was x to the second, x to the negative 24, which is x to the negative 22, which is 1 over x to the 22. This one was w to the negative 2, w to the 5, which is w to the third. So simplifying a product raised to power, this is kind of like a Common Core-ish type problem you might see on a multiple choice. It says, which expression represents the area of a square? Well, let's think about this for a minute. How do you calculate the area of a square? What do you do? You're given one side length, length times width, and for a square, the length and the width will be the same. So you're really just taking that length or the width and squaring it, right? That's what it means to be a square. Its dimensions are squared. Okay, guys. So in a square, you're going to take the one length given to you, which is 5x cubed, and you're going to multiply it by itself or square it. I'd like you to write it like this, because then it connects to what we're doing now. Okay, if you write it 5x cubed times 5x cubed, it's like what we did last time. So according to our new rule, what do we do with this squaring here? What does the 5 become? There would be a 5x cubed here, and there would be a 5x cubed here. So what's, it's going to be 5 to the second, and then x to the 6th, right? And 5 to the second is 25 x to the 6th. So 25x to the 6th is answer choice D. Okay. So what these are dealing with, and I'm going to do one more of them here. I think I'll do this last one, is when you have a number paired with a letter. Okay. Okay. A number paired with a letter. You have the choice. You always have the choice. So here we would have 3 to the negative 2, g to the negative 8. Okay, we're applying the negative 2 power to the 3 and also to the g. And then because both of these are negative, you're going to move them down to the bottom. So this will equal 1 over 3 to the positive 2, g to the positive 8. And 3 to the positive 2 power, we can do that, right? It's just 9. It's 1 over 9 g to the 8. So with this as an example, and this as an example, I'd like you to try these two right here. And then we'll put the solutions up. Cool. What is it? 43. Did you try it on your calculator? So take 7 to the third power. Do it on your calculator right now. Make sure you can do it. 7 to the third. Yeah, 343. Good. 343. You guys need to know how to do this on your calculator. 343 m to the 27th, and you're done. This one right here, 2 to the negative 4, x to the negative 4. So then I move them both down. It's 1 over 2 to the 4, x to the 4. And that's 1 over, you know what 2 to the 4 is? It is 2. So 1 over 2 to the 4. What's 2 to the 4? Fourth. Powers of 2, we should know. At least 2 to the 5th. 2 to the 3rd is 8. 2 to the 4th will be 16. So we've got 1 over 16 x to the 4th. All right. It's about a full game. All right. Last couple here. What I'm going to have you guys do, we're going to split today's lesson into 2 parts. You're going to do the classwork today for homework. You'll start it in class, and then you're going to do the homework tomorrow in class. I will give you time to work on it. And then I also have another review, a little assignment that we may get to. It depends on how this goes. But so tonight you're going to do the classwork. We'll get started on here today. Here's about as hard as they get. Simplifying an expression with products. What is the simplified form of each expression? So here I've got n to the 1/2 to the 10th. What does the rule say to do with these powers, the 1/2 and the 10th? You've got a power to a power. So we multiply the 1/2 times 10. And then here with the 4m n to the negative 2/3, we're going to take the 4. What's the power on the 1? Or the power on the 4? It's a 1. Right? The power on the 4 is a 1, right? So we're going to multiply the 1 times the 3. The power on the m is also a 1. Okay, guys, I thought you need to stop.
Keeps offering me banana bread.
That's hard to refuse, but yeah. And then it's really not. And then we've got to take negative 2/3 times 3. So we've got this third power. You have to apply it to the 4, to the m, and to this fractional power of negative 2/3. You're multiplying it by each of those powers. So the 1/2 times 10. That's easy to do. It's n to the 5th. And then here, 4 to the 3rd is 4 times 4 times 4. So 16 times 4 is 64. And then I have m to the 3rd. We just copy that down. And then n to the negative 2/3 times 3. So we're going back to our arithmetic here. Do we know how to do negative 2/3 times 3 over 1? What do you get? It is a 2. It's a negative 2 because of this negative sign here. These cancel, and I'm left with n to the negative 2. Now, this is not simplified completely because I have 2 n's in the problem still. What do I need to do on the powers on n's, Gracie? What do I need to do on the powers on these n's?
Have them.
Man, stole her thunder. So it's 64, m to the 3rd, and then n to the 3rd as well. I'd like you to try. I want to see that you can do these on your own. This is like your classwork, because you're going to do your classwork for homework. Jonah and I will come and check it. So try these last 2 and write your summary. We will come and check these and make sure you can do it. You got them done already? Okay. Both of these right here. Both of these. And then you can start on classwork.